Have you ever wondered about those little hand warmers that just magically heat up? Or what about an instant cold pack that goes from room temperature to icy in like 2 seconds? Well, today we're going to pull back the curtain on the amazing chemistry that makes it all work.
So, let's start with a big question. Why does a fire make you feel all warm and toasty, but a cold pack literally feels like it's sucking the heat right out of your skin? They seem like complete opposites, don't they? But what if I told you the basic principle behind both is pretty much the same?
The secret, it turns out, is all about chemical reactions. Yep, that roaring fire and that freezing cold pack are both powered by chemistry. And by the end of this, you'll see exactly how they pull it off.
Okay, first up, let's talk about the hot stuff. We're going to look at reactions that actually give off energy. You can think of these as the energy givers of the chemical world.
So, the official term here is an exothermic reaction. The most important thing to remember is that it releases energy. It's kind of like a tiny power plant, you know? It converts all this stored up chemical energy into heat that just radiates outward, warming up everything around it.
And the classic example, the one we all know, is just burning something. Fire! When charcoal burns, its carbon atoms are grabbing onto oxygen from the air. That little chemical dance unlocks a ton of stored energy and boom! You get the heat and light that we all see and feel.
This diagram here just nails the whole concept. See how those arrows are pointing away from the beaker? That's the energy. It's flowing out of the reaction and into the surroundings. And that, right there, is why the temperature goes up.
All right, so we've covered the energy givers. Now let's totally flip the script and look at the opposite, reactions that actually get cold. Let's meet the energy takers.
So, unlike its hot-headed cousin, an endothermic reaction needs to pull energy in from everything around it just to get started. By absorbing all that heat, it actually makes the area around it feel a whole lot colder.
And here's a super fun one. You know that cool fizzy tingle you get from sherbet candy? That's actually an endothermic reaction happening right there on your tongue. The chemicals in the candy need energy to react, so where do they get it? They steal the heat right out of your mouth. And that's what creates that signature cooling sensation. And again, this diagram tells the whole story. Remember the last one where the arrows pointed out? Well, look now, they're all pointing in, towards the beaker. The reaction is literally pulling heat energy in from the environment, causing the temperature all around it to just drop.
So this isn't just some weird science for labs and candy. Not at all. These two types of reactions are cleverly engineered into all sorts of products that we see and use all the time.
Just take a look at these two. On one side, you've got a can of soup that heats itself. On the other, an ice pack that gets cold on demand. They're perfect, real-world examples of our two reaction types in action.
So how in the world does that hot can work? It's genius, really. Inside, you have two separate compartments, one with calcium oxide, the other with water. When you press the button, they mix. That kicks off a powerful exothermic reaction that gives off so much heat it actually warms up the soup or coffee around it. And the cold pack? It works on the complete opposite principle. You've got a pouch of water, and inside that, another little pouch of a chemical like ammonium nitrate. When you squeeze the pack, you break that inner pouch. The chemical dissolves in the water, and this whole process is endothermic. It sucks in heat from everything around it, making the whole pack feel freezing cold almost instantly. All right, let's put it all together and do a final showdown to make sure these key differences are crystal clear.
So let's just boil it all down. Exothermic reactions, they give energy out. That makes the surroundings warmer, so the temperature increases. Endothermic reactions, they take energy in, which makes the surroundings colder and the temperature decreases. It's a perfect mirror image. Now it's your turn. Just by looking at the change in temperature, you should be able to tell what kind of reaction is happening. Let's see how you do.
Okay, check out the table. Reaction A goes from 20 to 25 degrees. Temperature went up, so that's exothermic. Reaction B goes from 20 down to 16. Temperature dropped, so that one's endothermic. And reaction C, it went from 18 all the way up to 24, another clear exothermic reaction. See? It's all in the temperature change. And here's the main point of all this. This isn't just theory. From self-heating meals for soldiers to instant cold packs for athletes, harnessing these simple energy changes allows us to create some incredibly useful technology. And now you know the secret. So the next time you light a match, or heck, even feel that chill when you get out of a swimming pool, think about where the energy is going. What other hidden reactions are happening all around you?